Hi chemists, welcome to your very first video on our unit called Periodic Trends. And you may first say, what is a trend? Well, a trend is really just a pattern, and the periodic table is amazing because there are so many patterns within it. So in order to set us up for success as we continue on with this unit, you need to learn some of the basics of the periodic table. By the end of this video, you should be able to describe how the modern periodic table is arranged, explain basic similarities and differences among groups and periods, locate and label common groups on the periodic table, locate and list properties of metals and nonmetals, and describe what a metalloid is. The person that's usually given the most credit as first, creating a version of the periodic table is Dmitri Mendeleev. In 1869, he organized the elements by increasing atomic mass, and so that the elements in the same row have similar properties. There's a great TED Ed on the genius of Mendeleev's periodic table. If you wanted to, you could absolutely Google it, and it's a pretty cool video, and it talks about basically how Mendeleev had a bunch of cards that he wrote the element names on and symbols, and he arranged them according to what he saw in terms of their properties. After Mendeleev arranged his periodic table, Moseley came around 1913, and he thought Mendeleev's table was pretty good. However, there were some inaccuracies in his table, so it needed a little bit of revision. And so what he ended up doing was rearranging the elements in order of increasing atomic number. And this is how the modern periodic table is arranged today. The periodic law says when elements are arranged in order of increasing atomic number, there is a periodic pattern in their physical and chemical properties. On the periodic table, there's a special name for the horizontal rows on the periodic table, and they're called periods. Sometimes, if you look in textbooks, you'll also see them called series. For the vertical columns, you'll see that these are called groups, or sometimes called families. Elements in the same group have very similar properties, and groups are numbered 1 through 18. Elements in the same period, however, do not have similar properties, but your periods are numbered 1 through 7. One of the things that they do have in common, though, is that these elements have the same number of occupied energy levels. There are some special blocks on the periodic table. The S and the P blocks are called the representative elements. The D block is called the transition metals, and the F block, which is not pictured in this particular diagram, these are called the inner transition metals. There are some common names for specific groups on the periodic table. For example, group 1 are the alkali metals. Notice I did not include hydrogen in that. I deliberately drew the arrow pointing straight to the lithium and over the hydrogen, because hydrogen is technically a nonmetal. Group 2 are called the alkaline earth metals. Group 17 are called the halogens, and group 18 are called the noble gases. The staircase is a really important part of the periodic table. It begins in between the boron and aluminum, and it can go all the way down, just like you see here. This staircase is really important because it helps to separate the metals and the nonmetals. So on the left-hand side, you have the metals, and on the right-hand side, you have the nonmetals. As I mentioned, remember hydrogen is technically a nonmetal, so hydrogen, while it is grouped with the metals, it actually behaves as a metal sometimes, so that's why it's technically on the left-hand side. Also, aluminum is touching the staircase, and we'll talk more about the significance of that later. So here are some properties of metals versus nonmetals. Metals are located, as I mentioned, on the left of the staircase. Nonmetals are on the right. Metals are lustrous or shiny, whereas nonmetals are non-lustrous or dull. Metals are also malleable and ductile, which basically means that you could change their shapes really easily. But if you try to change the shape of a nonmetal, they break, and so they're often referred to as brittle. And finally, you probably know this, but metals are good conductors of heat and electricity, but nonmetals are poor conductors, but they are good insulators. Metalloids are substances that touch the staircase and they have properties of both metals and nonmetals. And remember what I said, aluminum is a special circumstance. Aluminum, although it touches the staircase, it is technically a metal, so it is not a metalloid. Metalloids are also called semiconductors, which means that by themselves they normally don't conduct electricity, but they will if you do certain things to them. So, like for example, if you heat them up, or if you add certain substances to them and create a mixture, they will conduct. This is a really cool phenomenon to demonstrate how elements in the same group have similar properties. If you're lucky, hopefully your teacher will do a demonstration for you that will show you what lithium, sodium, and potassium look like when you add them to water. Hopefully this video helped you understand many of the properties of the periodic table and sets you up for success for the rest of this unit. Great job, chemists. Thank you so much for watching.